Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Today we would like to present you our project. There are two projects. We are from K3CSM 3401 Internet of Things. My name is Firas Amirah binti Rosni. The other team member is the other team member are Muhammad Faez bin Musa and Athirah Ellysa binti Rosli. Next, I will like to pass to Athirah Ellysa for the presentation.
Hello. Okay, for the introduction of the group assignment, we have two projects to be complete to finish the task. Which is for project one, we need to design a circuit using MicroPython to program the ESP32. For this task, we need to control the dim or the brightness of the LED using the potentiometer. While the project 2, we need to establish a connection to Wi-Fi connection to read the temperature and humidity of the current environment using DHT11 and store the temperature and humidity data to the Faber IoT cloud. Okay, next for the detail of project 1. Okay, for the objective of project 1, which is we have three objectives, which is first to learn how to program ESP32 by the MicroPython. The second, which is to study how to control the dim of the LED using potentiometer. And the last one, to analyze the reading of the output. Okay, next, which is problem statement of the project one. Okay, the eh, the dim lamp sometimes make the people become uncomfortable to make some routine as they feel dazzled by the lamp. Some people, especially students, cannot focus on the reviewing the lesson or study in the middle of the midnight with a dim or the very bright lamp. The problem statement of the project one, the dim lamp sometimes make the people become uncomfortable to make some routine as they feel dazzled by the lamp. Some people, especially the student, cannot focus on reviewing the lesson or study in the midnight with a dim or very bright lamp. They need to adjust or control the brightness or the dimness of the lamp on their own to make them comfortable and focus, which is can improve their mood and also the productivity to the study. So here, students need to control the dimness of the lamp to feel more comfortable during study and can use it to dim the sleeping light to wake up early in the next morning. So the proper solution for the problem statement, which is we need the minimum requirement uh, for this project, which is ESP32 and USB micro B cable. Second, potentiometer, third, breadboard. Fourth, jumper wire. Fifth, resistor, and the sixth one is LED. How to set up is for the proper solution. First, we need to make the circuit connection according to the schematic diagram, which is we will show in the result and discussion later. Okay. Second, upload the code into the ESP. This code will be demonstrated by the another member. Okay. The third is after that we need to run the program, and the next we need to make adjustments to the potentiometer. And lastly, we can see the output and LED display. Okay, next is methodology and or flow chart. So here we choose a flow chart to show our step for project one, which is for the starting. Okay, for the flow chart, for the project one. Okay, first of all, the potentiometer need to be adjusted to the lowest range of zero. The reading will be received by ESP32 via pin 12, and the reading will be printed out by the ESP32 on the UPyCraft output display. Next, the brightness of LED will follow the value of the potentiometer that we adjusted earlier. If the value of the potentiometer received by ESP32 is 0, then the LED will be dim. If the value of the potentiometer received by the ESP32 is above 0, then LED will be bright according to the value of the reader received. Next, ESP32 will delay for 5 seconds. And finally, the program will continue to repeat if the stop button is not pressed. So, next for the result and discussion, I would like to pass to my fellow friends to describe the more detail about for our project.
Okay. Assalamualaikum warahmatullahi wabarakatuh. So I am Muhammad Faez. I will explain the schematic diagram of the first project. So first of all, to install the circuit, pin 14 ESP32 need to be connected to a 220 ohm resistor, and the resistor need to be connected to the LED anode pin. While the LED cathode pin need to be connected to the ESP32 ground pin. Next, pin 3.3 volt is connected to pin 1 variable resistor, and pin 3 VR is connected to pin ground ESP32. After that, pin 12 of the ESP32 is connected to pin 2 of the VR via ESP via a 220 ohm resistor. The use of resistor on the anode side of the LED is instead to reduce the current following, so that the current following from pin 14 of the ESP32 does not exit the LED load. This is because LED only require 1.5 volt to 2 volt only. How does this circuit function? ESP32 receive current reading from pin 12 sent by variable resistor. The value of this current is determined by variable resistor adjustment. If the variable resistor is adjusted to 100 ohm, then the total reading on the pin 12 will be 0.01 amperes. Therefore, the total resistance is 100 ohm plus 220 ohms and divided by voltage value of 3.3 volts. The highest resistance value of the highest current value received by ESP32 in pin 12. Okay, so this is the component. If you can see, the square one is ESP32, and the left side we have LED on the board, and it's connected to potentiometer and resistor to 220 ohm. Okay, so this is the result before we rotate the potentiometer. The brightness of the LED is lower. Next. So this is the output when we adjust the potentiometer to the highest value. The highest value. So the LED, the brightness of the LED will getting higher. So for the next slide, I will pass to my friend, which is Firas Amirah binti Rosli.
Next, I will continue with project 2. For the objective of this project, we will learn how to write Python code for establish a connection to Wi-Fi network, read the temperature and humidity of the current environment using the HT11 or 22 and store the temperature and humidity data to the favored IoT cloud. The second one is to study how to control and use the HT11 or 22. And the last one is to analyze the reading of output. Okay, for the problem statement, nowadays people would like to know the temperature and humidity in their house. It is because they can prevent a house fire from happening as they are not alert when the temperature become rising when they are not around their house. Other than that, the higher temperature of humidity can also affect our health. This is because we can get headache and dehydration if the temperature is higher than normal range temperature. While the high humidity can have a number of adverse effects on the human body, which can contribute to the feeling of low energy and lethargy, and it can cause hypothermia. So here, the people need to establish a connection to the Wi-Fi network to get the reading of the temperature and humidity of the current environment in their house. Okay, for the proper solution of that problem statement, for the minimum requirement needed for this project is ESP32 and USB micro:bit cable. For this project, we will use DHT11 and favor IoT free account and also Wi-Fi connection. Okay, for the step, firstly we will create favor IoT cloud account. Next, we will set new project, set up new application, set up new group, and set up new device. After that, we will create rule. If humidity more than 70 or and temperature more than 29 and send SMS warning temperature is too high into headphone. After that, we will install the DHT11 component and an LED according to the diagram schematic. After that, we will upload Python code into ESP32 using UPcraft, or we can also use Tony. And we will run the program. After that, we will look at the data stream near the favor IoT cloud to see the output. Okay, for the methodology or flowchart, first of all, the ESP32 needs to be connected to Wi-Fi. If successful, ESP32 will display Wi-Fi detail on UPcraft output. If the connection fails, then ESP32 needs to reconnect. After that, ESP32 needs to connect to the Favor IoT cloud and ESP32 will read the temperature and humidity reading on pin 15 delivered by DHT11. After that, the reading will then be published to the Favor IoT cloud. If Favor IoT receives a temperature reading above 29 degrees or a humidity less than 70, then Favor IoT will send an SMS to the mobile phone. The process will continue until the stop button is pressed on the UPcraft software. Okay, for the result and discussion, I will pass to my friend Muhammad Faez to continue.
Okay, so this is the schematic diagram for project 2. To install the DHT11 on ESP32, the first thing, the voltage in pin on ESP32 need to be connected to the VCC pin on DHT11. If you can look at here, it connected from V in 5 volt to VCC DHT11. V in refer to the voltage source where the ESP32 supply a 5 volt voltage from the V in pin. This is a requirement for DHT11 because the DHT11 requires at least 5 volt to operate. Next, pin 15 on ESP32 need to be connected to pin data or signal on DHT11. This connection is intended for the ESP32 to receive a signal from a voltage from DHT11. Next, the ground pin on the ESP32 need to be connected to the ground pin on DHT11. And how this circuit works? The DHT11 receive a 5 volt supply from ESP32 to function. The DHT11 detect air temperature and humidity. DHT11 will provide a voltage signal to ESP32 from data pin to ESP32 pin 15. The voltage depends on the temperature and humidity reading of the air. The temperature reading detected by DHT11 is higher than the reading on pin 11 of ESP32 is also high. So this is the actual circuit when we connected DHT11 to ESP32. So the blue color one is DHT11 and the square, the big square here is ESP32. So this is the result after we upload the code into the ESP32. So before the ESP32 connected to the Wi-Fi, the LED here become green and there are no reading on the screen. So next. So this is the result after ESP32 connected to the Wi-Fi. So the ESP32 start to detect the temperature and humidity and send the data into the ESP32. And if the result is success, the LED will the blue color of LED will bright. The reading will show on the Tony and Faber IoT Cloud platform. So for the next slide, I will pass to Firas Amirah binti Rosli.
Okay, thank you, Muhammad Faez. Okay, for the conclusion for project 1, we will know there are two ways to change the LED brightness. The first one is we can adjust the resistor value. We add a potentiometer in series with the LED. When you adjust the knob of the resistor, the brightness of the LED will change. The second one, we can turn the LED on and off quickly. Another method is to turn the LED on and off fast, maybe a few hundred times per second. Usually you want to use a microcontroller for this. By adjusting the percentage the LED is on versus off, it will appear to the eye that the brightness change. Okay, for the conclusion for the project 2, both of them are interchangeable, meaning that you can just replace the DHT11 with DHT22 or vice versa. The wiring for both is exactly the same. Okay, the difference between DHT11 and DHT22. In this project, we will use DHT11, but we also can use the DHT22. But there are some difference between both of them because DHT11 is a bit smaller than the DHT22. DHT11 also less expensive than DHT22. DHT22 is better than the DHT11 in every aspect, from temperature range, temperature accuracy, humidity range to humidity accuracy. Okay, that's all from us. Thank you.
Okay. This is the code for project 1. In the line 1, we are importing the class of pin, ADC and PWM class. So So the next line we import the time.sleep class. And after that, in line 4, we set the GPIO14 as a pin and 500 Hz as frequency. So we set the LED pin in pin. We set the LED in pin 14. And the next line, which is the line 6, we're creating the potentiometer objects, and we assign the potentiometer in pin 34. The next thing is we're setting up the ADC resolution to 10 bit and the full range 3.3 volt in line 8. So next, reading the analog pin in line 11, and we print up the value. We print the value of potentiometer in line 13. And next is the LED will setting up the brightness according to the potentiometer value. So if the potentiometer value is higher, the brightness of LED will go higher. And if the potentiometer set up to low, the LED brightness will become low. And this process will loop forever until somebody click stop on the UI graph. Jadi ini adalah kod untuk projek kedua. So pada line pertama ni, pada baris pertama, kita import library network. Lepas tu kita import library masa pada line kedua. And then daripada DHT kita import kelas DHT 11. Seterusnya kita import library pin daripada machine. And then kita import library MQTT client daripada MQTT sample. Untuk line seterusnya kita set DHT 11 pada pin 15. Dan kita setkan server kepada mqtt.favor.iot.com. Okay, ini server MQTT yang kita pakai untuk projek ni. Dan kita setkan client MQTT client kepada API key Favor IOT cloud account kita. And then seterusnya jika ESP32 connect dengan Wi-Fi, if the betulan is connected, dia akan printkan connecting network. So dia akan tunggu. And then dekat sini kita akan letak SSID name dengan password Wi-Fi kita. So sekiranya Wi-Fi kita connected, ESP32 kita connected dengan Wi-Fi, dia akan print dia punya status lah kat sini. Dia punya detail, dia akan print kat sini. So untuk proses yang seterusnya, ESP32 connected dengan client server. Jika dia connected, dia akan print OK. And then DHT22, DHT11 akan start membaca data temperature dan humidity. Dan dia akan letakkan di dalam variable T dan H, di mana T adalah temperature, H adalah humidity. Kemudian ESP32 akan printkan temperature data yang diambil oleh DHT22. So untuk proses yang seterusnya, data tersebut kita letak dalam JSON and then kita hantar ke server. Lepas kita hantar, kita disconnect klien tu dan kita delay selama 5 saat. Dan proses ini akan terus berulang dan berulang sehingga seseorang menekan button stop pada UiPath. So mari kita tengok output. Saya ada membuat rakaman tentang output projek 1 dan projek 2. Mari kita tengok sedikit rakaman yang telah saya lakukan bersama rakan-rakan dalam grup ini. Ini adalah output setelah kami upload kod kepada ESP32. So jika kita lihat di sini, dalam waktu sekarang ni potentiometer dilaraskan kepada nilai yang tinggi, lebih daripada kosong. Jadi LED akan menyala. Dan sekiranya potentiometer dilaraskan kepada value kosong. Bila kita tengok sini dia akan jadi kosong. Kecerahan LED akan menjadi malap. Prosesnya akan berulang lah. Sebabkan Y dia akan berulang. Ini adalah output untuk projek kedua. Mengesan suhu dan kelembapan udara. Setelah kita upload kod kepada ESP32 menggunakan Tony, pada waktu sekarang ESP32 perlu berhubung dengan connection Wi-Fi. Sekiranya ESP32 berjaya connect to Wi-Fi, proses mengesan suhu dan kelembapan udara akan bermula. Signal akan dihantar terus ke ESP32 dan sekiranya ia berjaya, LED biru akan menyala. Dan output data kita boleh tengok dekat bahagian output Tony ni. Dan dia akan hantarkan ke IoT platform.